guess I'll go first. So let me show you how to solve type 1 binary compound.
Here are the steps we need in naming type 1 binary compound. But before that, you should always get a table of elements besides S. So let's have an example first. CS3P. So step 1 is to identify which type does the chemical formula belongs. So step 2, find the name of the element in the table. So the elements we have are CS for cesium and P for phosphorus. So after identifying the elements, all you have to do is to take the root word of the last element and add IDE. So phosphorus will be phosphide. If you combine the two of them, it will be cesium phosphide. Another reminder that in type 1, we disregard its charges. So now from its compound name to its chemical formula. So let's have the same example, cesium phosphide. So step 1, find the symbol of each element. So balance them according to their charges. So we have CS with 1 charge and P with 3 charge. So we have to balance them to make it correct. So we need 3 CS or cesium to make them balance, and our chemical formula will be CS3P, and that's how we do for type 1 binary compound.
You got it?
That was easy. For sure for this next item, you'll get this one. But first, what is type 2 binary ionic compound? Type 2 binary ionic compound is a compound which is a metal that can form more than one type of cation is bonded to a non-metal. Typically, transition metals are used for this kind of compound. And this is how you name a type 2 binary ionic compound. Step 1. Write the name of the metal. In our case, Sn represents tin. Very basic, right? Step 2. Find its oxidation state and write it in Roman numerals inside a parenthesis. In our example, phosphorus has a charge of 3 negative, and there must be 2 of them. If you would multiply the two numbers, you would get 6. Well, there are 3 tin in this compound. Think of a number that if you would multiply to the charge of the metal, it will balance out the non-metal. In our case, 2 would do. Therefore, you have to write it like this. I also have a tip. The oxidation state of the metal can also be quaternary if you would look at the charge of the non-metal. But remember, this might not be applicable every time, so be careful. Step 3. Get the root word of the non-metal and add IDE, just like what Tolitz told us earlier. Tada! That's how you name a type 2 binary ionic compound. This time, I'll teach you how to write the formula of type 2 binary ionic compound. Step 1. Write the symbol and the oxidation state of the metal. This charge is in Roman numeral form. So we have Sn2 positive. Step 2. Write the symbol and the oxidation state of the non-metal. In our example, we have phosphorus as our non-metal. If you would look it up in your periodic table, phosphorus has a charge of 3 negative. So you have to write P, 3 negative. Step 3. If you ended up with 2 same charges, then you're done with your formula. However, if you ended up with 2 different charges, you have to find their least common multiple. Similar to our case, the least common multiple of 2 and 3 is 6. So we have to divide those two numbers with 6. And then you will get Sn3P2 as the formula of tin2 phosphide.
Okay, I got it. I think I understand type 3. Here's how you will name the type 3 binary compound, which is called binary covalent compound. So let's begin. Here are the steps or rules to be followed. First, the element in the formula is named first, and the full element name is used. The given is S2O. For the first step, you'll just have to maintain or copy the first element in your chemical formula. Let's identify the first element. The symbol is S. S stands for sulfur. But there's a number 2 beside it. What's that for? I'll discuss about that later when we arrive at step number 3. Then, the second step is to get the root word of the non-metal and add IDE. The second element is O, which is oxygen. We must get the root word of the element, which is ox, and add IDE at the end. This will give us the answer, oxide. So let's proceed to the third step, which is prefixes are used to denote the number of atoms present. Here, You'll just have to look at the given and beside the element symbol. A while ago, I pointed out the number 2 beside sulfur. That indicates the prefix that we need to use in naming. But what do you call that number 2? It's a subscript. It indicates the number of atoms present. The prefixes are mono for number 1, di for 2, tri for 3, tetra for 4, penta for 5, hexa for 6, hepta for 7, octa for 8, nona for 9, and lastly, deca for number 10. Prefix for number 2 is di. Here, you just have to add the prefix di in front of the first element based on our given. But this only depends if the first element has a number of atoms beside it. But we need to add prefix in the second element, and we are going to use the prefix mono. I'll give you guys a reminder. If the first element only have one atom, you don't need to add the prefix mono. But why did we add the prefix mono in the second element? It is because the rule says so. Rule number 4. The prefix mono is never used in the first element. And we will arrive at the correct answer, which is disulfur monoxide. When transforming a name into chemical formula, you need to look and analyze the given. The prefix di in disulfur means 2, and the symbol for sulfur is S. In writing the subscript, it should be beside the element symbol. So we have S, and the subscript is 2. And then look at the second element. The prefix is mono, which means 1. And if the number of atom is 1, we are not supposed to write it. So we will have the element symbol for oxide, which is O. Combining them together, our answer will be S2O.
Okay, those 3 types of binary compounds are basics. Can someone show me how to do polyatomics?
I got you, bro. So, first,
You must first look at the given if it belongs to the polyatomic compound. So let me give you an example. Ba, open parenthesis, ClO4, close parenthesis, 2. So remember that in here, we must put the cation first before the anion. So first is to identify our element, which is Ba. So second, find our anion, which is ClO4. So we just have to combine them with the cation first, followed by the anion. So we have barium perchlorate. Now we will find the chemical formula of a compound name. So let's have the same example. So first step, find the symbol of the element. So second step, find the symbol of our polyatomic ion, which can be found below the table. So step 3 is to balance them. So we have Ba with 2 charge and ClO4 with 1 charge. We need 2 more perchlorate in order to balance our compound. So the ClO4 must be in parentheses to avoid confusion with our subscript 2, which is to be put outside the parentheses. And with that process, we will have Ba, open parenthesis, ClO4, close parenthesis, 2. And that's it for our polyatomic compound.
So, that's how you do it, huh?
I think I'm getting the hang of it, but acids kinda confuse me.
Not to brag or something, but I can teach you how to do it. Now let's talk about naming acids. Step 1. We're going to break the 2 ions from this chemical formula. One is 1H plus charge because it is an acid. And the second one is 1F minus charge. It has to be minus because the charge of H is 1 plus. And it has to be balanced. The negative ion that we're working here is F. Step 2. We're going to figure out the name of the negative ion. After we break the ions into 2, we can now proceed to finding its name. In the negative ion, the 1F minus charge stands for fluoride that we're going to use in naming. Step 3. We're going to name the acids. We are now done with the first and second step. We can now move to the third and last step. In naming an acid, there's rule to be followed. If the negative ion's name ends with the letter IDE, we will take away the IDE, like in our fluoride. Then after that, we will put fluor between hydro and IC, and it will be hydrofluoric acid. If you follow these steps, you will now able to name acids. In this tutorial, you will know how to transfer chemical name into chemical formula. Step 1. If we will look in the hydrofluoric acid, it begins with hydro. So we will use the rule in this acid, so we will type H. Step 2. We will look at the stem. As we can see, it is fluor. After that, go to the periodic table and look for fluorine. We will see the element symbol F, so we will write F. The third and final step is we need to balance the charges. As we can see, H has always plus 1, and F has negative charge. And if it will add up, it will result to 0. So the net charge is 0. thus made the HF the formula of hydrofluoric acid.